Welcome to RT2 Lesson 1. Your learning target for today is I can write linear equations. Okay, so there's 3 different ways to write your linear equations, and here they are. The first one is called standard form. It says ax plus by equals c. I apologize for that typo in your notes. A, b, and c are all integers. The second one is called slope-intercept form, which is y equals mx plus b. M is the slope, B is the y-intercept. And the third and final is called point-slope form, where M is the slope, and then we're given a point where it's x1, y1, and we have that there. Okay, let's take a look at some examples. If we look at these lines, we can write them in slope-intercept form. Let's start with the green line. So I'm going to start with 1 point. And I'm going to find another point on my line, and I'm going to identify the slope by counting up 1, 2, 3 over 1. Notice that each, it's going up by half, that's the scale. Then I can add in the y-intercept. For this one, it is at positive 2. Then we can substitute it into slope-intercept form, because that's what we're asked. So y equals, m is the slope, so 3 over 1, which is 3. X plus b is our y-intercept, which is 2. Go ahead and try the blue and the red lines. Press play to check your answers, and then we will go through the yellow line together. So again, try the red and blue lines. Go ahead and check your answers. The blue line has a negative slope, so make sure that the slope was negative 3. Let's try the yellow one together. I'm going to identify 2 points on my line, so here and here. We're going to find the slope, 1, 2, 3, over 1, 2. And I do not see a y-intercept, and we can't just make the y-intercept up, so we actually need to find the y-intercept. So for this, let's look at our points. I'm going to pick the point 2, negative 2, and we're actually going to use point-slope form this time to help us solve for our y-intercept. So remember, it's y minus y1 equals mx minus x1. So we're going to use our point x1, y1. So y minus negative 2 is y plus 2 equals, my slope is 3 halves, and then we have x minus x1, which is 2. Now, if a problem says to just write an equation, you could leave this as your equation, because this definitely is an equation of a line. It's actually in point-slope form. If it says it must be in slope-intercept form, then you would need to do some solving for y to get it to look like that. For now, we're just going to leave this because it is an equation. Let's take a look at an example. Write an equation of a line that goes through the points negative 3, 4, and negative 5, 0. Notice it doesn't say it needs to be written in point slope or it needs to be written in slope-intercept form. For this one, we can find our slope. And then I would say let's use point-slope form because we have a point, and substitute all the information into that form, and we can leave it like that. Okay, so our slope, remember we need to find the change in y values over the change in x values. So our y values are changing 0 to 4, that would be negative 4, it's going down 4, negative 5 to negative 3, that's going down 2. So our slope is 2. And we can substitute that into our formula along with our point. And I'm going to choose to use this point. You could use either point, but I'm going to choose to use this one. So my y value is 4. My x value is negative 3, so this becomes plus 3. And here's our equation. This is in point-slope form. If it said it needed to be in slope-intercept form, what we would do is we distribute. So we'd have y minus 4 equals 2x plus 6, and now we need to solve for y. So we'd add 4 to both sides, and we'd get y equals 2x plus 10. Let's look at another example. Write an equation of a line that goes through the 0.04, and for -3. So first, we need our slope. We're going to look at how the y's changed. It went down 7. Then I'm going to look at how the x's changed, and it went up 4. So we get -7/4 for our slope. Now we're ready to put it into our equation, and I would use point slope because we have a point and we have our slope. So y minus y1, I'm going to choose to use this point for -3. So it'd be y plus 3 equals our slope, -7/4, x minus x1, which is 4, because we're using that second point. Here, we can leave this. This is considered point slope form. We could also go ahead and write it in slope-intercept form by distributing first. So y plus 3 equals -7/4 x plus -7, because the 4's would cancel once we distribute. So then I'd subtract 3 on both sides, and I'd get y equals -7/4 x minus 10. And this would be in slope-intercept form. Either one is an equation. It just depends if the problem asks you to write it a certain way. If it does not, you could choose either. Let's take a look at example 3. Write an equation for the line with slope 2 that passes through the midpoint of a segment with endpoints -111 and 5, 5. So this one requires a little bit different. We've been given our slope. We need to actually find the midpoint because it wants to go through that point. So we can find our midpoint knowing our endpoints. To find the midpoint, we are going to take the average of our x's. So -1 plus 5 divided by 2. We're going to do the same thing with the y's. So find the average of the y's. 11 plus 5 divided by 2. So our midpoint is 2, 8. Since we now have a point and a slope, I'm going to substitute this into point slope form. Y minus y1 equals m x minus x1. Again, we can leave it like this, or if we needed to change it into slope-intercept form, you could do some distributing and solve for y. Okay, let's try another run. Write an equation for a line that slope 1/2 that passes through the midpoint of a segment with endpoints 2, 16 and 10, -8. Go ahead and pause the video, try this one on your own, and then press play to check your answer. You should have first found the midpoint, 6, 4, and then you should have found your equation. Y minus 4 equals 1/2 x minus 6. Example 5. Find the equation of the perpendicular bisector of the segment with endpoints 2, 3, and -6, -5. So this time we're not given the slope, and we also need to realize that it's a perpendicular bisector. So it's going to cut the segment in half. So that means I need to find my midpoint again. I also, since it's perpendicular, I will need to find the slope of this segment and then use its opposite reciprocal for the new slope. So we're going to find the average of the x's, 2 minus 6 divided by 2. Average of the y's, 3 minus 5 divided by 2, to get a midpoint of -2, -1. So the equation of the line needs to go through this point. We also need to find our slope. And we need to find the slope of the original segment because we want our new slope to be perpendicular to that. So let's see how our y's are changing. It's going down 8, and then our x's are changing by going down 8, which equals 1. The opposite reciprocal for the perpendicular would just end up being -1. So we're going to use this point and this slope to write our equation. Y minus y1, which is -1, so it becomes y plus 1 equals m, our slope, which is -1, x minus x1, which is -2, so it becomes x plus 2. If you needed to write it in slope-intercept, you'd need to distribute and solve for y. Here's another example similar to the last one. I'd like you to go ahead and try this one on your own. Press play to check your answer. You should have found the midpoint then you should have found the slope of those 2 points. And to find it to be perpendicular, we use the opposite reciprocal, which is how I got negative 3/5. Substitute our point and our slope into slope-intercept form. I mean, point-slope form. You could always change it to slope-intercept form if that's what you're asked for. This one is similar to the last two. You can go ahead and try it, or I will walk through my thinking on this one if you'd like to watch and take notes. Find the equation of the perpendicular bisector of the segment with endpoints 6, 0 and 3, 3. So we need to find the midpoint of our 2 points because it's a bisector. So we have 6 plus 3 divided by 2, 0 plus 3 divided by 2. Our point is 4.5 and 1.5. Now we need to find our slope because it's going to end up being perpendicular. So using these points, we have the change in y, which is 3, the change in x, which was negative 3. That becomes negative 1. So our slope is going to be the opposite reciprocal since it's perpendicular. It would be 1. We're going to use these now, our slope and our point, and substitute into our formula. Y minus y1 equals m, or 1x minus x1, which is 4.5. A final example, and I would like you to try this one on your own and then press play to check your answer. Here you go.